Problem 10.8. Prove that the equation, the integral between 0 and x of e to the t squared dt is equal to 1 has a unique solution in R, and that it can be found in the interval 0, 1. Okay? So one way to prove that this, for instance, it's obvious that so if we call f this integral, right, between 0 and x of e to the t squared dt, right, f at 0 is going to be 0, obviously, right? And it seems obvious that when x gets big, right, it gets greater than 1, because this integrand becomes greater than 1, right? So then this is going to be greater than the minimal value this takes, and so for instance at 1, f at 1 is going to be, let's say, between 0 and 1, e to the t squared is greater than 1, greater or equal than 1. So f at 1 has to be greater than 1. Okay? So, well, applying when the Bolzano's theorem, if you want this function between -1, so f at 0 -1 would be negative, f at 1 -1 would be positive, so there has to be at least one root inside. How do we prove that it's unique? Well, we compute the derivative of this function, and then we have to see that this is only increasing or only decreasing. In this case, we know that it's going to be increasing. What's the function of the derivative of this is e to the x squared, but we know this is always positive, right? So the function is increasing in this interval, and we have that this -1 is negative at 0, this -1 is positive at 1, so then that proves the result.